In the previous video, we learned how to approach projectile motion problems, as well as solve two of the example problems. The third one I decided to leave for this separate video because it requires just a few more steps. However, our general approach will be the same. So if you don't know how to solve projectile motion problems yet, I advise you watch that first video. But if you already watched it, keep watching how to solve this more complicated problem right here. So, a cannon positioned at the edge of a cliff fires a cannonball with an initial speed of 30 meters per second. So from the cliff right here, we have this velocity at an angle of 45 degrees. Then it goes like this. It reaches some maximum height until it goes back down. All the projectile motion problems, all of them are broken down like this: to the maximum height point and from the maximum height point. So this point right here of maximum height is very important. We have to then basically calculate all these different things. So the first step is to sketch the problem. The second step will always be to find the x and the y component of the velocity. That is, if the velocity is at the angle, you always look for its x and y component. So sine of 45 degrees is equal to opposite side Vy over the hypotenuse 30. If we multiply both sides by 30, we'll have 30 times sine of 45, which is equal to 21.2 meters per second. Then, similarly, we'll solve for Vx by doing cosine, right? Cosine of 45 is the adjacent side over the hypotenuse. So cosine of 45, so ka-toa, so adjacent over the hypotenuse. So Vx is 30 times cosine of 45, which will also be 21.2 meters per second. Now that the first step is done, that is, we made a sketch and we found the x and y components of our velocity, let's make a table. In the x direction, which is non-accelerated motion, we have delta x, velocity, and time. In the y direction, right, I can just read off all my variables here. So it's going to be these first variables right here: final velocity, initial velocity, acceleration, time, and I'll call this delta y since it's displacement in the y direction. Now let's write down everything that we're given. So of course, we just found these initial velocities in x and y respectively. So let's put that in our table. What else do we know? We also know that we also always know that the acceleration is negative 9.8 meters per second squared. We can always put that for acceleration in the y direction because the only acceleration in this problem is the gravitational acceleration. And we need to solve for the time. So we still need one more variable in the y. Where we're going to get it from if we weren't given that number? So since I know that at the maximum height, Vy is equal to 0, that's what I'm going to put as the third variable right here. This is a very important trick, that at the maximum height, the velocity of y is equal to 0. That's why we always break down the projectile motion to the maximum height and from the maximum height. So let's take a look at this. The variable we don't care about in this case, so we don't need to calculate it and we weren't given it, is delta y. So if we don't have displacement, we should select the first equation right here. All right, let me select it. Okay, so the first equation will be Vf is equal to Vi plus At. Final velocity is 0 because again, we're at the maximum height. Initial is 21.2, acceleration is 9.8. So again, now I'm just rearranging it by subtracting 21.2 from both sides and dividing by negative 9.8 on both sides to find the time it takes it to go from this till up. Once I plug it into my calculator, is 2.15 seconds. Now, they did ask for the total time. So now we need to calculate the time it takes to go from the maximum height till the bottom over here. And what I need to do is I need to set up this as the second part of the problem. So I need to set this up separately. Now, if I consider now this as my initial moment and this as my final moment, right? My initial velocity will be 0, right? Because again, I'm starting at the maximum height. So in the y direction, my velocity over here is 0. My acceleration is still negative 9.8 meters per second, and I still need something else. I still need another variable. So what I'm going to do actually is I'm going to find the maximum height that it reaches, right? So its maximum height is going to be determined by the 50 meters right here and the extra kind of delta y that it travels right here, right? Okay, so let's come back to this equation. Now I actually do need to find the displacement. So I can, for example, I can use any equation that has the displacement. This one, just the last one, looks the simplest to me, right? Just the simplest one to set up. So delta y is equal to initial velocity plus final over 2 times time. But you could have solved it using this or this equation. So my initial velocity was 21.2. My final velocity is 0 divided by 2 times the time that I just found is 2.15. I get delta y is equal to 22.82 meters. Now, that's basically the extra height that it traveled up above the cliff. So the maximum height, right, like delta y max, let's call it, is 15 meters. So the height of the cliff plus 22.82 meters or 72.82 meters. So the only thing that I have found so far, right, has been the time it takes for it to reach the top height, as well as the maximum height that it goes to. Okay, so now I can solve the second part of the problem, which will be the time it takes it to go over the air. So, and by the way, this is part C as well, because we solve for the maximum height. So now to solve for the total, now that I know delta y is 72.82 meters, I can set up the second part of this problem. Let's take a look. The variable I don't care about is the final velocity. So based on this, let's pick our equation. Without the final velocity, what I should do is select the first equation right here. So delta y is equal to initial velocity times t plus 1/2 at squared. One more time. Right now, what I'm doing is I'm solving for the time it takes it to go from this top height to all the way to the ground. This is my initial moment, this is my final moment. So the velocity at the top height is 0, the acceleration is negative 9.8, and the total height that we just calculated that it reaches is 72.82 meters. Since I have to calculate the time, the variable I don't care about is the final velocity. So I pick the second equation that doesn't have any final velocity. My initial velocity is 0, so this term cancels out and becomes 0. And if I want to rearrange for time, I can multiply by 2 on both sides, divide by a, and take a square root of both sides. So the time that it takes it to go up is 3.85 seconds. Now, if the time it took it to go up was 2.15, the time for it to go down was 3.85, then of course the total time right here will be 2.15 plus 3.85, or approximately 6 seconds. So guys, that is the total times it takes for it to go in the air. Again, the key to solving this was really just to break down this motion into two parts. So everything you can for the first part of the problem. So we solve for the displacement and the time, and then solve everything for the second part of the problem when it goes from the top height to the bottom. Okay, we are almost done with this problem, right? Because we already calculated the maximum height over here as 72.8, and we have calculated the time. Now we just have to calculate the range of the cannonball. So that is, what is the horizontal distance? But it's really easy since we know the total height, since we know the total time is 6 seconds, we can calculate delta x Just like we did in all the previous problems, the delta x is equal to v times t, right? Our velocity is 21.2, our time is 6. So therefore, delta x is 1.27.2 meters. All right. Hopefully this was helpful. Keep practicing, keep doing these problems because that's how you get better, and keep watching these videos on the way to an A. Thank you.